Let's continue our discussion of the thermal simulation workflow by talking about the opaque envelope. Remember that the envelope is essentially that everything that surrounds the building. It's separating the inside from the outside. And so here's our little one zone model that we were playing with earlier. And even this simple little box is an architectural model, not something we can use for a thermal simulation. And that's because it has thickness. So we have an interior volume of air, the inside. We have a ceiling here, for example, and then there's an assembly that is more than just a surface separating the interior volume from the outside. That's great in an architectural model. So if we look at a little tiny building, it's very simply designed. This is an architectural model. We have thickness to the walls. We have windows that are set back from the exterior surface, which they very, as they very well might be in the real world. And of course, we can design and develop an architectural model to whatever complexity we want to. And our other simulation geometries will be completely based on that, but they may be different. And so we have to remember that, or we'll just get functional problems with our modeling workflow. So let's talk about that in a little more detail. If I turn on what I'm going to use, the layers I'm going to use for my thermal model, what's the difference? Well, first off, if I turn off the opaque, actually let's turn off everything. I've got an envelope, an opaque envelope. Opaque envelope, again, meaning just that those parts of the volume that's separating the inside from the outside that are not windows, or they're not glazed. And so the first thing we notice is that it's not as tall as the architectural model. That's because this parapet is not part of what's separating. It's not part of the. It's not the outside edge of the volume that's separating the inside from the outside. And why is that important? Because all we're dealing with in a thermal analysis is that part of the building that heat is flowing through, and by proximity, air and water vapor and liquid water, etc. So that's what our opaque envelope is then. It's just a surface that surrounds that air. And let me turn off my shading overhang. So, okay, that's great. Makes sense. Then why does it look like we have two windows, two sets of windows and these two doors here? That's because if we go back and look at the architectural model, we'll remember that we had our windows set back as they might be with a reveal. And so they cannot be used for the thermal model because they are not coplanar with the opaque envelope. So that's the first thing is really important. We're only talking about one point thick surface that goes around the entire volume of air that's our zone or our building. And why is that important? Well, if I don't think that way and don't model these windows as in the exact same plane as this, this and this have to be in exactly the same plane, then I will get errors. So just as an example, let me turn this off, and I'm going to turn on the zones that I use in a different simulation. So here they are. And let me show you how you turn these on and off, by the way. So if I'm over here in my thermal simulation window, I can click on this preview settings and turn on or off whatever I want to see. Oops. So, whatever. I'm going to turn them all back on. And I can see my windows in my opaque envelope. If these windows were not coplanar with this wall surface, then when I added them, I would have, and sometimes you don't even notice this, but once you learn about it, you will, that I would get a, down here there would be another drop down that says invalid objects, and then inside that, just like, that ground boundaries inside this ground boundaries, all the windows would be inside of there, and there would be a little red border around these. I don't have one made that's faulty right now, but just be conscious of that. And what would happen? Well, you can still run the simulation, but it just wouldn't be accurate. Okay, so I'm going to go back to my thermal simulation. I suppose the only other thing to say about that is that remember that the shading is a little different. It can be the same uh, form or geometry as in your architectural model. You just have to make sure that you identify it as shading, and add it here in the thermal model. And again, that's where you have to. Modeling is a conscious act, right? You run things and then you go, wait a minute, that's not what I think it should be. And you'll often find you just made a mistake. You got to be organized. That's why if you look at, I'm pretty organized over here with my layers. I've got a lot going on in this model because I'm doing all the videos out of it and adding to it. And I wouldn't be able to do that if I wasn't organized. And I still have made, have done many runs where I think, what's going on here? I have to go figure it out and then redo it. That's just the process. Okay, so let's go back to the model we were working on earlier. We'll remember that we had, close this down. Let's see, we had this building with a core. Let's see, how was it oriented like this? And we had stairs, elevators, whatever. Let me ground plane. There were apartments. It was a little bit larger apartment building, and then we set the our thermal model as an apartment inside a single apartment inside this building, right? And we made the point and did a number of runs with this adiabatic surface defined. So the red surface, let me just turn off all that red are surfaces that are coplanar with other parts of the building, and therefore in our model we said no heat was moving through them. And we made the point that then this apartment is already has very little surface area exposed to the outside, and that's really going to affect the way it performs. So then let's to so in this case, then in a larger building, the envelope is going to have less of an effect, the opaque envelope. So let's not think about an apartment right now. I mean, or a larger building, and just think of this building as a small little house. Let's see. Let's add a little bit to it. So let's say this is an entrance over here. There would be a door here, but since it's opaque, we're not going to add it in because it's just in this model it would be the same as the wall. We have a little porch or balcony outside, in an overhang over the entrance. This is a north-facing side of the building. We have and it's also the entrance, so maybe we would want windows that are higher for daylighting, but that allow privacy, etc., whatever. It's a little simple design. We're coming out to an outdoor area here, so this is a double door. So one point to make that I may have made before is that Climate Studio, the model, well, it's not just Climate Studio. Energy Plus, which is the modeling engine Climate Studio uses, is not really designed for smaller buildings, single-family homes. They have a different sort of physics to them. But let's just, as part of learning, let's try to cheat the system a little bit and adjust our settings to try to approximate a house. So let's go in and look at that. I've actually created just a couple of templates. We can talk about how that's done here. I want to start this house as a what I, my guess as to what a 60s single family home, 1960s, um, what the settings would be. So we haven't looked at this in a while. Let's just dive back into it for a second. I'm in the load section, and these again, I preset these. I'm just going to tell you quickly what I did, or even partially. We'll talk about settings in a lot more detail in a different video when we get more into more complex models. But so I changed the number of people. I think this is set for like one person for every 500 square feet. I added a residential schedule, so we're seeing that this is basically saying this is when people will be there. They're going to work or school or whatever during the day. They're there at night. So that means that then their heat from this metabolic rate. Remember, we're little heaters constantly putting out heat as we metabolize food. This is defining when the people that those heat sources will be in the building. I set equipment and lighting power densities that were pretty high because in 19, like for example, this would be based on incandescent lights rather than LEDs. I didn't have any dimming. I think that the basically all the conditioning settings I left the same because they may not, those might pass in terms of the comparison between a single family home and a larger building, which is what these templates are designed for. And then I created settings over here. I'm leaving the same. We'll talk about that in a different video. That's just for cost and carbon. Then I came in and I changed my my envelope setting. So let's just talk about this section again a little bit and get into a little bit more detail with it. Remember, we have these different surfaces that we're defining our envelopes for. So I created, so let me just, I'm going to start with the roof. I'm thinking 1960s. I just said it's going to be all concrete, no insulation. There's very little insulation in 1960 anywhere. I don't think a house is probably going to be solid concrete. This is, I'm just having a little making things easy. But what did I do? How did I create this custom assembly for for this portion of the envelope? This is how you do it. You pick whatever you want as your baseline. Doesn't matter because I'm just going to delete it. But let's say I'm going to use, actually I'll even do this. So I'm going to search for 90.1. We've talked about that a little bit yet. I'll start with exterior wall in climate zone 4 that meets the 90.1 standard. And then I'm going to duplicate it. Just going to call it test because I'm going to delete it. You can see that there's categories here that just going to, it's a list you can put things in. I'm not going to, I mean, it will be set in a list in your library. If I say OK, then I can come down now and here's my test facade, and I can edit it now. And it's just a test facade, a portion of an assembly. I mean, I can choose which zone based on those zones that are graphically shown at the beginning. I'll show you those again. And I can add or subtract layers here. So I can, let's add something. So, and if I don't want it to be a default material, I can open it up and pick from this huge list of materials. So whatever, I'm just playing around here. And then I can change the size of it. This is in feet, so if I wanted it to be 2 inches thick, or let's say make it easy, a half a foot, 6 inches. And then if I open it up again, see there's my oak there. So that's how you can create a custom envelope for whatever purpose you have. I think I might have been confusing what I was saying. So I added that as a roof that every envelope you open will have all of these subsets, and you can choose what you either pick a preset. So for example, if I go back, I'm going to completely get out of here. If I go and select some preset, actually, let me do it this way. I'm going to select my zones and edit them. I'm going to go to apply a template. And if whatever I pick will have presets for everything, and including different presets for these envelopes. And so I can say, okay, I like these, or I can click on any one and either choose a different template. So like here's my test from before, uh, or just keep what's in if you want to work quickly, you can accept the presets and do simulations very quickly, almost effortlessly. All right, so I'm going to go back and apply a template again. I'm going to go back down to the one that I created, which was, and what does this mean? A413, that's our class. SF is single family, 1960 baseline. So I'm basically saying, let me open it up, that, and I'm going to just show you what I wrote. So to do that, I'm going to have to say save as template. So here's the name. Well, actually, this is a different template, but it doesn't matter. And so that's the name I created for that one. I put it in a residential category, and I gave a little description here. So it's easy to be organized. Let me get back out of that. Or actually, I'm going to go apply a template. I just chose the wrong one. So I'm choosing this one because I want to start with a very an old school envelope. So here is, actually I see now I must have changed this at one point by accident when I was doing a different run and saved it. So I can go set this up the way I wanted it to be. So I'm going to say I want my 1960s roof that I've already created. I click on this. I can type in 1960. Here's the roof that I created before, which is total concrete or completely concrete. Say OK. I want to have my 60s exterior wall. And by the way, so what is a 1960s wall to me? Well, solid concrete. I've got a U value that's not very good, and so in other words, just less than one of an R value of less than one for the entire assembly. Concrete is very poor at resisting the flow of heat, though it can store heat. Just remember too, I have embodied energy numbers here that I could change. Thermal capacitance just basically means that the concrete can hold heat, which it does affect how heat moves through it. Okay, so then I would do the same thing. Here's my 1960 partition. This looks good. I'm going to change the external floor to I'm just going to make that the exterior wall. What is the external floor? You see, it's like if you have a cantilever here. So I think that would be the same in this case as the rest of the walls. So I made it the same. I'm going to change this to 1960 slab. Oops. Ground slab. And even though I don't have a ground wall, which means something that's underneath, that's got earth against it, I'll go ahead and use the ground wall setting that I made. So now I have all of these envelope assemblies that I want. I'm going to leave the rest of this as it was. Say OK. Oh, and see what happened there. I didn't actually save that. Now it's going to be in here if I open this again. The things I just did are in this run, but it will not have been in the template. So if I wanted to make that a template, I'd have to go and save that as a template here. And I can just do that. I'm going to save as template. I'm going to call it 1960. Oh wait, A413 single family 1960 baseline, and say no. I'll say OK. And it should be, if I go to my library now, that should have been saved. Let's see if it's true. Come back down to my here's the template in question, and yeah, those presets are there now. Awesome. Okay, so now I'm out of here. Then I need to set my windows. Let me show you a trick on that. If I open up, by the way, let me close these back down again. Over here, I can either open everything or collapse everything. That's a good thing to be able to do. If I open everything and select holding shift, I can now go and edit. If I hit edit, I don't want to change anything in the zone, so I say OK, and then the windows will show up next. And I can change my windows here all at once. So this is changing all the windows to the same thing. It's default glazing, which is what I wanted. Default glazing has a U value of 1, so R1, really bad. Lets most of the sun in, solar heat gain coefficient of 0.9, and lets most of the visible light in, a visible light transmittance of 0.9 also. And so then if I let me make sure that I've got my shading on, because let's just go ahead and actually let's collapse these. Shading objects. Let's see if there's that one and that one. Yeah, so that's the two shading objects I want. And I have, let's see if I've got my ground set. Yeah. All right, so this model is ready to go. I run it. Remember, it's running over here in the background on my other screen. And here's my results. So sort of ignore this actual number in terms of the baseline here. This baseline is set for a medium office because there is no single family home. So anyway, we're just learning the workflow here. We're not really trying to get something accurate. But so we have a lot, obviously a lot of work we can do. We have really large losses in the envelope. The windows, once we get this under control, we'll look at because they'll have more of an effect. All right, so now the advantage to having the fact that in physics the surface that the heat and air and water vapor are moving through are just the exterior of the building, then we do not have to change that surface area as we change the envelope to iterate our thermal analysis. So let's do that. We've started with, and I've already run all these, so I'm going to maybe show a little bit more of the settings just to remind us how it works. But then we'll just run through sort of an idea of something about how we think about this and use an envelope simulation as part of our design. So this is our first run, and we said that there's things we can work on here. So let's first let's just upgrade the opaque envelope itself, because right now it's solid concrete like it would have been maybe done in the 60s or sometime not in the too distant past. Buildings have changed a lot. We've require much more energy efficiency than we used to. Anyway, so let's go and look at our let's see, we'll close that. Let's edit our envelope. And one thing I realized I didn't, I think I went too quickly before when I was showing you that test. So let me just go back to my tests that I was showed as an example. Is it clear what's going on here? Is that we have, in this envelope, here's the outside, here's the inside, and we just have a series of layers. So this is a section, a horizontal section through the envelope. So out here we have stucco, and it's 0.082 feet thick. Then we have concrete, number 2, which is 0.66 feet thick. Then some mineral wool insulation, then plaster for number 4, and then number 5 I added oak on the inside, just whatever. And you see how thick it is compared to the other. So we can change the thickness and then see the graphic change here. So I'll make it really thin, 0.15. That's actually just like an inch or so, or 2 inches. Um, so that's how we can very easily create our own custom assemblies. In any case, let me get out of here. I don't want tests. Oh, I don't want any of these. I'm gonna close out of this, and I'm gonna go to I'm gonna apply a template. And I made a code reference version of this where I changed the envelope. So you see automatically these changes came in. These are 90.1 standard 9.1 residential climate zone 4 exterior roof, for example. I left some of the 1960s because I don't think the partition needs to be any different, or the floor slab. Anyway, these are things that you should talk to me about in terms of your actual designs. But I'm just trying to teach you the workflow right now, so I'm going quickly. So that looks good, and then I run it. That's all. If that's all I'm changing, then just showing that I'm running it. Now, like I said, I'm going to stop running these. I'm just going to show them to you, the results. But so from that first envelope to the second, we had a huge improvement in our site EUI. And do you understand this is the energy use intensity? This is a good quick, if you're just looking for a quick summary of the thermal properties of your building, basically how much energy you're using, this is the number to look at. So we can see that this is the one I just ran, right, the 201, and this is going to be the same as this one. Right, so I'm going to go delete these two, and then the rest I'm just going to show you what the results of the runs I made and what I changed. So I started with my 1960s envelope with default glazing, so just single pane glass. Then I changed to a more contemporary envelope with insulation. I didn't really show you that, but basically there was insulation in the roof, the walls, a little bit in the slab. But I had the same glazing, and that had a major effect. Let's see if we can see what actual effect we had. First off, so in the previous one, this is another great thing about this interface, is I can just switch back and forth really quickly. I've mentioned before, if this ever slows down a lot, I found that for me, if I just close everything down and open it again, close Rhino down, open it again, it speeds up. I'm not sure what's going on. Something gets clogged up in the math, and it can get really sluggish with the switching between these runs. Okay, so I have in my first run, I have really large cooling loads. Heating loads in the winter, and substantial cooling loads also. I could probably work on the equipment and the lighting, which are these two at the bottom. So red is heating, blue is cooling, gray is equipment, and yellow is light. Then if I change to, I improve my envelope, we see that I drastically reduced my heating loads, and then I have increased cooling loads. Let's see how much. They aren't increased. So I'm about at 27 here in July. I'm still at about 27 here, so it's just that the heating loads decrease so much that they change the scale over here. And let's see if we can then see what the difference is. If I go back to the first one, I have lots of, and remember we're at 0 here, and then above that is heat gains, below that is heat losses, and the really light gray is mechanical system adding, because the heat losses and the gains have to balance out. That's the whole point, is that if we lose a bunch of energy in our envelope, we're going to add it with heating, with the HVAC heating system. That's the basic idea of this graph. So we have, again, this is the 1960 envelope. And I think all we did mainly was we added insulation essentially, and drastically improved the green is the envelope. but we have a lot of gains with the windows. It looks like that there's more power, so that this kind of um, uh, orange, or I'm sorry, rust color is equipment. Um, I think it's the same amount. It's just because the scale has changed. We're now at a much smaller scale now, right? So it looks like that's more. Okay, then what did I do next? Next, I just changed the glazing to be double pane 90.1 standard glazing. 90.1 meaning so 90 whenever I say 90.1, that's the contemporary sort of baseline energy code standard. So it's good, not great. Lots of people get to it. I mean, lots of projects get to it, but it's not 1960s. And so when I change that, I get a pretty hefty improvement to a 1 to 80 to 181. And what happened? I can see that just mainly, so the orange again is the windows. I am I have a lot less gains in the summer, which is good, and I have less gains in the winter, but I have also a lot less losses in the winter. Um, Next, I pumped up the envelope even more to a higher standard, more insulation. Um, I call it Passive House. Passive House is a German standard that's big in the United States now. That's very energy efficient. And so now that helps somewhat. The opaque envelope. Now remember too, we're not looking at how, this is a lot of glazing. We're not looking at changing that. We're not looking at shading it. Though we actually do in this model right now, we have shading on. So remember those two things are shade. But we don't have any shading over this expansive southern glass. So there's lots of things we could do. We're not designing here. We're learning the workflow. So the basic point is here that I got very little improvement, but some improvement in the envelope. You see how it just slightly tweaked, so that installation helped a little bit. There becomes a point of diminishing returns, which is a whole debate that people have. Then next, I changed to triple pane glazing, improved the glazing. And again, I'm going up incrementally. These are pretty major amounts of improvement, but this is a 1,100 square foot building. So, dropping your site EUI from by 5 kilobtu's per square foot is a lot. Okay, so the point is going from here with a basic old school envelope to here with better insulation and glazing, it's a crazy huge improvement. And we're not changing the architecture at all. I mean, we may be changing the thickness of the walls, so that's why you need to be thinking of this early on. But we're not having to, it's not getting in the way of our architectural design. And then going on from here, we're still using the presets for a really old mechanical system. There's no ventilation right now, so it's not really even a livable space. So the next thing I did was just update everything on the mechanical system side, and I'll talk about that later. But just to show you, that had a drastic, so mechanical systems and envelope together are what get us from 1960 to today in terms of state of the art. That jump that I'm just showing you there is how we can do local law 97 in New York City. If we're really trying to get to the highest standard of improving envelopes, highest standard of energy efficiency, we will definitely have to do a rebuild with the envelope, like a wrap or something of a building in New York City. But there's a huge amount we can do with mechanical systems, and that's what most people are going to do first, especially until it gets really stringent in 2030 or 2050. Okay, so we went a long way, and let's see what is it that changed here. I'm going to go back to my other. This is without any changes in the mechanical system. I'm sure that I dropped down this. Well, actually, I don't think I did. Let's see. Essentially everything except the envelope went way down. And so if you look at the scale here, right now that we're at this high point is 19,200. kBTU per year. If I switch to this updated mechanical system, this is now 7,000. So all of these are now much smaller. They're just, this scale is smaller. So we reduced our power usage for our equipment. We have same people, much lower lighting usage. I think I might have at this point brought in some controls. Our glazing is no different. So if we go back to this. This is the same levels. It's just on a different scale. We really I upped the infiltration or lowered the infiltration rate. So this is a huge change in the light blue here between here and here, and even on the scale, it's really changed. So that's a big part of it. Then the next thing I did was I added natural ventilation. I'll do a whole video on that. That knocked us down quite a bit too. And I also just tweaked some things. Just using my own knowledge. I think this is when I put in a photovoltaic control of the lighting, so that we have lights turning off when there's enough daylight. I tweaked the insulation slightly, etc. And we were able to get quite a bit more improvement out of it. Let's see. And again, I'm going quickly here. I should. Let's compare between. So right here, yeah, we have a lot of cooling load. And so that's why I added the natural ventilation. And again, that's a whole, I'll show you how to do that, how to simulate natural ventilation. And that is one of the main things that's adjusting that cooling load, because we're able to passively cool the space for different times of the year and not use power. Then finally, let's say we're at this point and we're really, we're trying to dial in to a design. And we don't really know, what the best way forward is. We can use these simulation workflows to really help us. So we can do it at the beginning. We can do it anywhere in between as we're trying to make a decision. Hey, let me just check and see what that did to my thermal performance. The thing I just changed. And we can at nearer the end of our design process, we can look at simple little changes that might have a big effect. So let's look at an example of something we could play around with. So if I go look at my energy flows again, and by the way, I haven't been looking at the zone temperature curves. There's other, this would be, let's see if we, yeah, pretty big difference, right? We've got a lot of hours outside the comfort zone for reasons that we've talked about before. We could talk about it in more detail. Anybody wants to ask questions. And then as we get a better envelope, we tighten this up until where now there's no hours outside the comfort zone. And again, that's just pushing a button. This is the same simulation runs. So if I go look though at my energy curves, my energy flows, and so this was the run we just did. And I see here that I have a lot of losses from my envelope in the summer, and also a lot in the winter, but it's the ones in the summer actually are to our advantage because it's hot outside and we're using the ground here as a heat sink, and it's hot heat's coming in from outside through the windows mainly probably, and then if we have a slab, for example, that slab is going to soak up some of that heat and then dump it into the ground. So in this case, I think this is the 90.1. Let's see. Yeah, it's sort of like it's probably R10 of insulation or something like that underneath there. So what would happen if we got rid of that insulation altogether and tried to even pull more of the heat out of the building in the summer? So I tried that, and I did actually lower fairly significantly my site EUI. Let's look at what other effects that had. So this is the one before with a little bit more insulation. So we have, just look at the heating loads and the cooling loads. They're both going to go down. And honestly, I'm not sure why our heating load is going down by taking insulation out of the slab. That would take some more analysis on my part. And I might have actually changed another variable too by accident. It's possible, and I have to go back and check it. But this is really what I want to compare between this and the next one. So this has no insulation under the slab, and we saw that we have a lot of losses all year round, but enough in the summer that we're gaining efficiency because we're dumping heat into the ground, and that's not having to cool. We have almost no cooling load here, I think, if any. Let's see. Yeah, you see just this tiny little bit of blue. So what happens if we then add a little bit of insulation underneath? So we're tweaking it. So now, what's hard is we went down, you know, significantly 5% maybe. And how did we do that? We so we added a little bit of insulation, which means we're not getting that heat dump effect as much in the summer. So we went from this to this, right? So now we're insulating. So that would seem like it's better, right? We're insulating, we're not losing as much heat, but since it's the summer, we're having to cool. So we lost that, but then I'm switching back. We're also not losing as much heat into the ground in the winter when we don't want to do it. So when we add a little bit of insulation here, we are then reducing our heating load while we're slightly increasing our cooling load, and we can see that happening here. So uh, heating load, almost no cooling load because there's very little insulation, or there's no insulation under the slab. We add some insulation, we reduce our heating load but increase our cooling load, and the overall effect was that this is the one before, this is one with some insulation, we reduce. So here's the basic point, the reason why I'm going into that kind of detail at this point in our very simple modeling. Uh, this is not something that would change anything about the architecture. It's not something that wouldn't cost very much at all. But if we don't think about it in a timely fashion, we're not going to include it in a way soon enough in the design so that it can happen. It's going to take up space, for example, if you add insulation, and therefore it might just be missed, or might get it value engineered out because it's too late because we've already done the site work or whatever. So even these it's never too soon to look at these things in a detailed way. And once you get good at this workflow, it's really pretty easy. So there's no excuse not to. And you're already in Rhino modeling, so why not?